So we are going to talk about valency of an atom. Valency is also known as oxidation state. So what does that mean, or how you are going to understand how valency or oxidation state is known, right? So let us see out here. So valency with respect to electron, as as the group number increases, valency also increases. As for sodium, valency is 1, magnesium valency is 2, aluminum valency is 3. So that is as how atomic group number is increasing, valency is also increasing. When we talk about with respect to oxygen, then going across a period, valency goes on increasing. That is how it has been observed in compounds. So, how do we calculate or how do we find out oxidation state or valency? What we do is we break all bonds attached to a particular atom, and the total charge that comes on the atom is known as oxidation state or valency. For example, I'll show you. If you have, if you have, let's say, let's see, if you have a compound SO3, so you have something like this. The structure is this. If you break all the bonds, if I break this bond, so more electronegative oxygen gets -2, sulfur gets +2. Same way, if we break these two bonds, oxygen gets -2, sulfur gets +2. I break this bond -2 and +2. What is the total charge on sulfur? If you calculate that, you will get +6. So the valency or oxidation state of sulfur in sulfur trioxide or SO3 molecule is +6. That is how valency or oxidation state is calculated, right? Next, if we see, if we grow across a period and with respect to hydrogen, if you see, then valency increases. In sodium hydroxide it is 1, magnesium hydride, but this valency is not of hydrogen, this valency is of the metal, right? What happens is hydrogen is less electronegative than non-metals and it is more electronegative than metals. So in sodium hydride, what the charge is, if I take sodium hydride, NaH, Na will be +1 and hydrogen will be -1. If I take magnesium hydride, what the charge is, magnesium has +2 and 2 hydrogen atoms are there. So each hydrogen has -1. So each hydrogen has -1, right? So that is how hydrogen in hydrides is always H minus. Metal is the atom which has variable oxidation state. Interestingly, if you see in group 1, all elements have +1 oxidation state. Lithium, sodium, potassium, rubidium, cesium, francium. Francium is a radioactive element, so we do not talk about that. But other elements have a +1 oxidation state. Similarly, in group 2 elements, you will see that they exist in their compounds in +2 oxidation state. They do not show variable oxidation state at all. For all group 1 elements, always they show +1 oxidation state or valency, and group 2 elements always show +2 oxidation state or +2 valency. Alright, this is something you should remember. And how to figure out which oxide is basic, which oxide is acidic, I'll tell you a simple trick. Just remember, most of the oxides of metals are basic. Oxides of metals are basic in nature, and oxides of non-metals are acidic in nature. I hope you can remember this. And what are the non-metals? Just remember those: carbon, oxygen, nitrogen, phosphorus, sulfur, halogens. These are non-metals. So their oxides are acidic. And oxides of metals. Metals means elements of S block, D block, F block. These are metals. So their oxide will be basic mostly. And what are amphoteric oxides? Acidic oxide is the oxide whose solution is acidic. Basic oxide has a solution basic or alkaline in nature, and amphoteric oxides behave as both acid as well as base. So oxides which behave both as acid or and as well as a base are called amphoteric in nature. So, which are those oxides? Zinc oxide, beryllium oxide, aluminum oxide, tin oxide, lead oxide. These are amphoteric oxides for you, right? So, we do have acidic, basic, as well as amphoteric oxides in our nature, right? And towards towards a same set of oxides, how you are going to figure out which is more acidic and which is less? So what is the trick? The trick is higher the oxidation state, more will be acidic character. Get it? So if I give you an example, I ask you, you have NO2, you have NO, which is more acidic? You will say oxidation state is here +4 and it is here +2. So this is more acidic. If I give you another example and ask you, let's say if you have CO and CO2. So in this, carbon has oxidation state of +2 and here you have oxidation state +4. So which is more acidic? CO2. So higher the oxidation state of element, more will be the acidic character. So this is a trick that you can figure out which is more acidic, which is less acidic. So that is it.